Okay, satisfaction or utility is maximized at the point where MRS is equal to P4/PC, slope of indifference curve is equal to slope of budget constraint. Marginal benefit from the consumption of one additional unit of good. Marginal cost of one additional unit of good. So we can then say that satisfaction is maximized when the marginal benefit, the benefit associated with consumption of one additional unit of food is equal to marginal cost, the cost of additional unit of food. The marginal benefit is measured by MRS. Different experience of consumers groups for automobiles. So we go back to earlier automobile example. Can affect their purchasing decisions. Following up on example 3.1, we consider two groups of consumer planning to purchase new cars. For example, that is a solution of young guys who prefer acceleration to space. Or that is a utility maximization point of some head of a family who prefer space to acceleration. Anyway, two guys face same budget constraint. Slopes of two goods same, right? The price of acceleration, the price of space same, face same. Two guys face same. This one, P4 or PC, for example, like this. But two guys have different tastes. In other words, their indifference map or indifference curve different with each other, reflecting their differences in preferences. The optimal solution is quite different. Young guys choose this point. This is a utility maximized point. At this point, more spending on acceleration than space. But head of household case, at this optimal point, purchase more space than acceleration, isn't it? Okay? That happens because of different preferences, difference indifference curve, difference utility function. Next slide. So corner solution, extreme case of utility maximization problem. Corner solution, situation where the marginal rate of substitution for one good in chosen market basket is not equal to slope of the budget line. Right? We already studied that at this optimal condition, this curve tangent with each other or MRS equal to slope of budget constraint. But sometimes that doesn't happen. Okay? For example, here, that is budget constraint. But indifference curve shaped like this. These guys have really spectacular preferences. Right? So higher preference to ice cream to frozen yogurt. So like this. Then this guy's whole income spent only on ice cream at this point. Right? That is a solution. But still, MRS is greater than relative price at the market. Price, slope of this budget constraint. At this point, still, this guy is eager to consume more ice cream, right? Willingness to pay. So MRS greater than relative price. So corner solution. When a corner solution arises, the consumer maximizes satisfaction by consuming only one of the two goods. Given budget line A, B, the highest level of satisfaction is achieved at point B. It's very clear from this graph, right? Well, at this point B, slope of U1, we can, right? Slope of U1, indifference curve, is still greater than the slope of budget constraint, right? That's one example of corner solution. Extreme case of consumer's utility maximization solution. Now we go next example. Consumer's choice of health. Figure 3.16, consumer preference for healthcare versus other goods. X variable is other consumption of other good. Y variable is consumption of healthcare services, right? So this indifference curve shows a trade-off between consumption of healthcare and versus other goods. Curve U1 applies to a consumer with low income families. Utility maximization solution should be here, right? As income increase, then budget constraints shift outward. For example, like this, right? Then curve U2 become feasible. The consumer moves point B. Income increase 8. Then consumption choice moving from A to B, like this, with greater consumption of both healthcare and other goods. Now think about this one at point C. Curve U3 applies to high-income consumer, high-income families' decision, and implies less willingness to give up healthcare for other goods. Moving from point B to C, the consumer's consumption of healthcare increased considerably from H2 to H3, while her consumption of other goods increased only slightly. When you moving B to C, what happened? Change in consumption, increasing consumption of other goods when your income increase from this one to this one is, then consumption of the other would increase O2 to O3, this amount, right? But moving B to C, consumption of demand for healthcare increased greatly. This one is larger than this one, isn't it? Right? Relatively poor families, income increase A to B from here to here. Consumption of other goods increases more greatly than demand for consumption of healthcare, isn't it? But if you become richer and richer, demand for healthcare increase more greatly than other consumptions. Okay, that is example 3.4. 3.5, a college trust fund. That is United States case, isn't it? When given a college trust fund that must be spent on education only, the students move from A to B. Originally, budget constraint in this one. And the government provides college trust fund. So your income increased by that. So budget constraints shift from here to here, right? But college trust fund means increasing this income only spent on education. So you have to moving A to B, 1 point on this new budget constraint, right? If, however, the trust fund could be spent on other consumption, in other words, increasing your income by government can be used education and other consumption simultaneously, then your choice should be point C, where new budget constraint touch highest utility curve. That is U3 greater than U2, right? So if, however, the trust fund could be spent on other consumption as well as education, the student would be better at point C. Your choice moving B to C. Anyway, budget constraint increase because of government support, right? Movement to A to B means this increase in income spent only on education. So this one, then your utility level is this one, U2. But increase in income can use both of good, then your choice should be at point C. At this point, your utility level is U3 greater than U2. Okay, next. Rebuild preferences. So rebuild preference, this section explains how to derive indifference curve, right? Based on indifference curve, not cardinal one, ordinal, more general, and ordinal indifference curve, differently from cardinal indifference curve. Until now, I explained using cardinal indifference curve. Utility level is $190, $80, like this. But more generally, we can derive indifference curve from this way, using information, rebuild information of consumer's choice. only ordering matter. Okay? So how to derive revealed preference right? If a consumer chooses one basket over another, and if chosen basket is more expensive than the alternative, then the consumer must prefer the chosen market basket or consumption bundle, for example, at point A. Right? If an individual facing budget line I1, you facing budget line I1. So you can choose point A and point B. Okay? But consumer choose A. That means utility at point A should be greater than utility at point B. But we don't know the numbers, but ordering is very clear. A prefer to B. Okay? Likewise, the individual facing budget line, if budget line is like this, which is then revealed to be preferred, and you choose B, then we can conclude that B prefer to D. All ordering matter. Okay? We continue this kind of process like this, like this, like this. And indifference curve is like this. Right? But repeat again and again, we can draw very smooth ordinal indifference curve. Can you understand? That is idea of section 4. Okay, example 3.6. Reveal preference for recreation. Right? When facing budget line I1, like this, an individual chooses to use a health club for 10 hours per week at point A. Choice is at point A. When the fees are altered, then budget constraint. Fees changes. So change this slope of budget constraint changes. For example, I2. Then your choice changes at point B, like this, right? She's then made better because market basket A can still be purchased, as can market basket B, which lies on the higher indifference curve. Right? Then you moving. Budget constraint changes, and your choice changes A to B. Then we know that B prefer to A. Okay? Okay. Now I already explained this kind of contents of this slide in the last lecture, second lecture, week 2, right? Using some graph and mathematically how to derive MRS, right? I already explained this. Marginal utility, additional satisfaction obtained from consuming one additional unit of food, mu F, mu C, like this. Diminishing marginal utility, principle that as more of good is consumed, the consumption of additional amounts will yield smaller additional utility, right? So you moving, for example, you moving A to B to A, right? We can make this kind of triangle, right? So this movement P to A can consist of movement P to C, C to A, right? So movement P to confusing P to C, right? P to C means at this point utility level is U star, right? And consumption of food only increase, holding consumption of clothing same. Then your utility level at this point B should be greater than earlier one because you consume more clothing, right? Holding consumption of the other constant. So your total utility increase. This one is mathematically, this one is me, right? mu F multiplied by change in F. That is the gap between the two, right? 10 or 20 in earlier slide, $10 or $20 in the last lecture's explanation. If you moving B to C, then what happens? Consumption of food same, but consumption of clothing decrease, leading to total utility decrease from U1 to U star. That kind of thing happen, right? Consumption of clothing decrease. That is this part, isn't it? Right? That is negative. Change in C is negative, right? So now we can draw this kind of triangle, P2A, like this. This movement from this one plus movement from this one to this one. In sum, 0. Total remaining your total utility, same. Right? Anyway, P2A means consumption of food increase. At the same time, consumption of clothing decrease, making your total utility constant, isn't it? Right? So effect of movement to here and here to here. That is this one plus this one. Then change in total utility plus 10 minus 10 or plus 20 minus 20. So 0. From here, we can calculate changing rate, change in C over change in F, mathematically, rephrasing this graph. That is, right, changing rate and absolute numbers of changing rate. So that is absolute numbers changing rate or MRS is equal to MUF over MUC. We already explained, right? And equilibrium condition says slope of indifference curve MRS, this one, is equal to slope of budget constraint PF over PC, right? I already explained. MRS is equal to this one. In other words, MRS is MUF over MUC. MRS is equal to PF over PC, right? That is this one. So this one. So we can get this kind of relations. This is, we said, equal marginal principle. Principle that utility is maximized when the consumer has equalized the marginal utility per dollar of expenditure across two goods here. Okay? Actually, you study all of this one in Menkyo's Introduction to Economics book, I think chapter 21. So marginal utility and happiness. What, if anything, does research on consumer satisfaction over utility tell us about the relationship between happiness and concepts of utility and marginal utility? Right? We already studied this kind of thing. Your income increase, then your utility level or satisfaction level increase and increase. Right? And that is dotted point is actual points, actual pair of income and utility. Right? This one, this actual value projected to this red line, that is fitted line. So in econometrics. Anyway, from here we know that X variable increase, Y variable increase with decreasing rate, right? Marginal utility and consumer choices. So rationing, right? Inefficiency of gasoline rationing. So that is also a US example, isn't it? Let's check. Okay, when a good is rationed, less is available than consumers would like to purchase. Consumers may be worse off, right? Without rationing, without government intervention, up to 20,000 gallons of gasoline is available for consumption at point B. At point B, right? The consumers solve utility maximization problem at this budget constraint without rationing is this point, at point C, where budget constraint touches highest indifference curve U2, right? Your utility level is U2 at this point C. Now government introduce rationing. The consumer choose up to, however, with the limit of 2,000 gallons of gasoline on the rationing. So each individual can purchase only 2,000 X variable gasoline. Then your budget constraint is here, and maximum consumption of good one should be 2,000. So then your choice should be at point D. Then you can draw indifference curve crossing point D, that is this one, dotted line. And we know that after rationing, utility level U1 is smaller than without utility level without rationing at point C, U2. Okay? So inefficiency of gasoline rationing. And comparing gasoline rationing to the free market. Right? Some consumers will be worse off, but others may be better with rationing. So it's a little complicated, isn't it? Right? So point D, what is point D? Rationing, and price is $1. Right? Then point D. No rationing, but price is $2. Price is $2. Then G is optimal point, right? And no, I'm sorry. Originally, original equilibrium is here, point F. I'm sorry, point D. This one, right? And point D is rationing when price is $1, right? And F is no rationing, but price is $2. So budget constraint rotate to the downward, and your choice is here. And now what is G? No ration, but price is in $1.33, right? Then you can draw this budget constraint, and your choice is G. Anyway, it's very clear that your utility level at point D greater than utility level at point F, right? Indifference curve and indifference curve like this, right? But you also know that so this U1 is indifference curve crossing point D, and point G are right side of this indifference curve, right? Then indifference curve crossing point G is a little somewhat higher than U1. We said U2 like this. So we can conclude that D prefer to G. G prefer to D. So sometimes that kind of thing, right? So when you compare D and F, right? Rationing price is $1 to F, no rationing, but price is $2. So rationing and no rationing. We studied the effect of rationing when the price constant in earlier slide. But price increase or decrease. Sometimes rationing can increase utility if accompanied with some increase in price, decrease in price, isn't it? So, okay, so think very carefully for this figure for yourself. And now, finally, we study cost of living index. So this slide the cost of living index. What is this? For example, consumer price index, wholesale price index like this. But there are lots of ways to measure that kind of thing. Basically, two in real world. Ideological cost of living index. We said IC, ideal cost of living index. Ideal cost of living index, right? That is, anyway, satisfaction level measured by utility. So this one should be like this. P1, U1, P1, I'm sorry, that is U0. Originally, you are some point on the one indifference curve. That is utility level, original utility level P0, for example, right? But in two periods, price changes. I said this kind of thing. So why? This one means vector in two goods, right? So P1 is P11, P21, right? U0 same, right? Like this. But in real world, we don't know. We can measure exactly this utility function, right? So we use instead spending, right? Budget spending, right? So, for example, P1, C0, P0, C0, like this, right? We use consumption bundle in real world. What is P1, C1? In two good case, that is simply P1, originally P0, C0, P10 plus, confusing, right? P0 and P1, P2, C2, 0, 0, right? That is the meaning of P0, C0. P0, C0 is like this because there are two good one and good two, like this, right? Then P1, C1 is equal to P11, C10 plus P21, C2, 0, right? So we use consumption, spending, right? Spending on good one, spending on good two, using ending price, right? And starting price is like this, right? We said that is last piracy index, right? So almost same to this one. But the other way we said partial index. Partial index is equal to this one, P0, C0, P1 instead of 0 over P1, C1, right? Partial index, last piracy index, using consumption bundles at ending point rather than a starting point, right? Then this one is P11, P10, C11 plus P20, C20. I'm sorry, that is 1. P0, C1, right? And ending value is P11, C11 plus P21, C21, like this. Okay? And conclusion is that ideal cost of living index should be greater than partial index and smaller than last piracy index. So last piracy index overestimates ideal cost of living index. Partial index underestimates ideal cost of living index. That is point, some conclusion of section 5. Okay, now we start chapter 4, individual and market demand. So in chapter 3, we studied utility maximization problem, right? From that procedure, consumption of two goods or demand for two goods decided. That is demand. So this chapter more deliberately studies this demand curve, right? So our analysis of demand process in 6 subsections. Section 1, driving of the demand curve. So individual demand curve is derived from each individual's utility maximization problem, right? Looking at the effects of price changes. Section 3, studying the characteristics of market demand. Market demand is summation of individual demand at each prices. That is market demand curve. Section 4, using market demand to measure benefits received. Section 5, so network externalities, right? So demand usually decided by utility maximization optimal solution, of consumers' choices. But some demand is not related to that kind of a rational choice of consumers. We studied that here. Section 6, obtaining empirical information about demand, mathematical explanation of demand curve, right? Okay, section 1, individual demand. So we already know that this kind of graph, isn't it? Effects of price change. So a reduction in price of food, which income and the price of clothing fixed, cause a consumer to choose a different market basket. Now look at panel A. The baskets that maximize utility for various food. Point A, $2. Point B, $1. Point D, $50, right? When originally utility maximization solution, when price of food is $2, utility maximization solution should be here, right? Budget constraint touch highest utility at point A, and consumption of food is 4. Okay? Now what happens when price of food decrease to $1? Then we know that budget constraint rotate to the right because P1 over P2, PF over PC decrease, right? Slope of this one decrease. So like this. Then at this new situation, consumers solve utility maximization problem again. Then find optimal choice of two goods at point B. At this point B, utility maximize. Okay? So this one, utility max, highest indifference curve at this, facing this new budget constraint. Now, price of food decrease again to $0.50, right? Then what happened? $1 to $0.50. Then price, the slope of budget constraint decrease again. So budget constraint rotate to the right further, like this. Then consumers have to solve utility maximization problem again with having different budget constraint. Anyway, there are the indifference curve, indifference map, right? And solve utility maximization problem again, and optimal choice happen at point D. At point D, consumption of food increase $20. Okay? Then we connect these 3 points, optimal choice point, A, B, C, then we can get this kind of thing. This is price consumption curve. Price of food changes, right? When price of food changes, then consumption or demand for food changes like this. Also, demand for clothing or consumption of clothing changed to 6, 4, 5, like this, right? That is price consumption curve. Okay? And from here, we can derive demand curve like this. When at this point A, price of food was $2. Price for food, $2. Now, X variable is for consumption too, right? Demand for food at point A is 4 unit. So point E is one-to-one relationship is point A, right? Difference at point A and point this one and this one is X variable same, demand for food same, but Y variable different, right? That is C2, clothing consumption, but now price of food. We already know that price of food was $2, right? Budget constraint is like this, then price is $2, then consumption of food is 4 units. At point B, price of food decreased to $1, $2 to $1, right? Then consumption of food is 12 units, so G, 12 units. So we can specify point G. So B and G also has a one-to-one relations, okay? And then what is point H? So point H comes from point D of price consumption curve, right? B to D, price of food decreased to $0.50. Price of food decreased to $1 to $0.50, right? Then demand for food or consumption of food increased $12 to $20, so H. If we connect this point, we can get this kind of individual demand curve. Okay? So, see, food consumption, clothing consumption, and price of X variable changes, decrease here at this example, then we can graph, trace price consumption curve. Okay? From this price consumption curve or this three utility maximization solution, we can find relationship between price of food and demand for food, like this. That is demand curve. So individual demand curve is derived from utility maximization solution when price changes. Got it? Okay, individual demand curve, price consumption curve. Curve tracing the utility maximizing combinations of two goods, optimal consumptions of two goods, as the price of one changes. Price of food decrease and decrease in earlier example, right? And individual demand curve. This relating the quantity of goods or demand for food that a single consumer will purchase to its price. Relationship between price and demand for that good. Okay? The individual demand curve has two important properties. Number one, the level of utility that can be attained changes as we move along the curve. Right? The level of utility that can be attained changes as we move along the curve. Okay? Price changes. Then consumers' purchasing power changes. So different purchasing power leading to different utility level. Think about price consumption curve, right? Price consumption curve. At point A, utility level is U1. At point B, utility level is U2, greater than U1. And at point D, utility level is U3, higher than utility level of U2, right? So level of utility changes as we move along the demand curve, right? Number two, at every point on the demand curve, the consumer is maximizing utility by the satisfying condition that marginal rate of substitution of food for clothing equals the ratio of price of food and clothing. In other words, these earlier 3 points, right? 3 points should be optimal consumption bundles of two goods. Solution of utility maximization problem. Okay? The condition for utility maximization solution is MRS, slope of each indifference curve, is equal to slope of budget constraint, respective. So that is PC over PF, right? 3 points satisfying this first order condition of utility maximization condition. Next slide. So income changes. So first we studied price of one good changes. Second case is what happens when income changes, right? So figure 4.2, effects of income changes. An increase in income, then what happens? Income increase, then budget constraint shift to the right, right? But slope of budget constraint, same. PC over PF is every time same, right? With the price of all goods fixed, causes consumers to alter their choice of market baskets. In part A, the baskets that maximize consumer satisfaction for various income. Originally, budget constraint here and consumer solve utility maximization solution to find optimal consumption bundles of two goods. That happened at point A. And individual consumers' utility level should be U1. Okay? Now, this individual's income increase, then budget constraint shift to the right, like this. But slope of budget constraint same, because only income changes. Price of food and price of clothing same. So slope same. Anyway, at this new budget constraint, consumers have to solve utility maximization problem again. And solution happen at point B, where MRS of U2 is equal to slope of new budget constraint, P3 over PL. That happened at point B, isn't it? Right? And now your income increase again, for example, like this. Then what happened? Anyway, consumers solve utility maximization problem again because budget constraint is now changes, right, from here to here. And solve utility maximization problem again and to find new consumption bundles of food and clothing. That happened. That is point D. So income increase, and this graph, consumption of food increase 4 to 10, 10 to 16. At the same time, consumption of clothing increased 3 to 5, 5 to 7. Okay? That is impacts of income changes. The shift to the right of demand curve in response to the increase in income is shown in part B. Part B is Y variable is price, X variable food consumption, same to earlier graph. I'm sorry, this one isn't it? Price of food, price of demand for food. In this example, price of food decreases $2 to $1 and $0.50. But here, price, no change. So, price of food every time, $1. But income increase, right? Then this one and this one and this one. Point E is one-to-one relationship with point A. G is related with point B. Point H is related to one-to-one relationship with point D. But Y variable is food, so horizontal demand curve. Right? That is explained here. So we said this is an income consumption curve. Curve tracing the utility maximizing combinations of two goods, demand for two goods, food and clothing, as consumers' income increase, budget constraint expand to the right, and finding new optimal consumption bundles of two goods. That is income consumption curve. In earlier example, here, price consumption curve, because price of food decreased $2 to $1 to $0.50 like this. Price consumption curve. But XY variable same, right? Here, same XY variable same, but income changes, so budget constraint shift to the right like this, and we can trace income consumption curve like this, right? Now, normal versus inferior good. Normal versus inferior good. What is inferior good? An increase in a person's income can lead to less consumption of one of the two goods being purchased. Then we said inferior good. Here, X variable is hamburger, Y variable is steak, demand for consumption of steak, right? Your income increased, then what happened? Your income increased, then budget constraint, right? Shift above like this, and consumer solve utility maximization solution again. Originally, A is optimal consumption bundles when your income is this one, right? Your income increase, you moving B, A to B. Then what happened? Consumption of hamburger increase, consumption of steak also increase, right? So when you're moving A to B, hamburger and steak is normal good because income increase, budget constraint expands, then demand for two goods increase. So two goods are normal good. Now think about when your income increase again, then you face new budget constraint like this. And solution of utility maximization solution facing this budget constraint occurred at point C. At point C, what happened compared to point B? Consumption of hamburger decreased here to here, right? Consumption of hamburger decreased. Income increased, then demand for that good decreased. That is definition of inferior good, isn't it? So when we're moving B to C, hamburger is inferior good. Can you understand? Also, sometimes then steak is inferior good or normal good when you're moving B to C. When we moving B to C, your income increase from this one to this one. Consumption of steak increase when you moving B to C, right? So steak is normal good. Income increase, steak increase. So steak is normal good. But when you moving B to C, hamburger is inferior good. So should be careful for this. So usually you have to solve this kind of some O-stripe question based on this kind of thing. Steak is inferior good or normal good. Hamburger is inferior good or normal good. Okay? Next slide. Now think about angle good. Angle good. Angle curves, I'm sorry. Angle curves, right? So angle curve is, so X variable is demand for food, consumption of food. Y variable is income, right? Income. So how this kind of angle curve is derived? Now think about this, right? Income consumption curve. Your income increase, consumption bundles of two goods changes, moving A, B, D. And here we draw price of food. Y variable is price of food and X variable is food. Demand for food is need, right? Then like this, price no change. Demand for food increase when your income increase or your budget constraint expands to the right. Angle curve is just same to this one, right? But here, Y variable is your income rather than price. So when at point A, your income is $10, for example, so your demand for food is 4. So this point. At point B, your income increased, for example, to $20. The income increased to $20, right? Then demand for food, $10. At point D, your demand increased to $40. So your income increased to $40 and demand also increased. So positive curve like this. That is just this one is income and food, demand for food, right? So this point is equivalent to panel A of earlier graph at A, I think. And this point is one-to-one relationship with point B earlier graph. And this is a point, income consumption curve of a point C or D, one-to-one relationship with point D of income consumption curve of earlier graph, isn't it? So that is angle curve. Okay? Now in A, food is, now angle curve is like this, right? So here food is normal good. Why? Income increase, then demand for food or consumption of food increase. So normal good by definition. But now think about panel B. So angle curve shaped like this. Income increase $10 to $20, then demand for hamburger increase like this. So when you're moving, income increase $10 to $20, hamburger is normal good. Income increase, hamburger increase, so normal good. But your income increase again, $20 to $30, then what happened? Your demand for hamburger decrease instead of increase, right? So when we're moving here to here, $20 to $30, demand for hamburger decrease. Negative relationship is income and consumption of hamburger. So inferior good at this case, okay? And the inferior good for income greater than $20 per month. Angle curve relating the consumption of a good to income, demand for good to income. That is angle curve. Got it? Okay, example 4.1, consumers' expenditures in the United States. We can derive angle curves for groups of consumers. This information is particularly useful if we want to see how consumer spending changes among different income groups, right? That is expenditures or demand for entertainment by low-income individual, right? Or this is demand for owned dwelling service by low-income, right? Low-income household. Or this is a demand for health care by this income household. Or demand for food, demand for clothing like this, right? Similarly, this one is demand for entertainment by really rich people in the United States. That is demand for clothing by rich income owner. That is demand for food by this group. This is a demand for health care by this group. Can you understand how to interpret, see this kind of table, right? So from here we know that income increase and increase. First, think about entertainment. Household income increase and increase and increase. This one is X variable, for example, right? Then what happens in demand, optimal consumption of entertainment? Increase, increase, and increase, right? So positive. And we know that your income increase and increase, increasing consumption of entertainment also increase greatly at this, for example, here to here, right? Consumption of entertainment increase, jump positively. How about owned dwelling? Income increase, then demand for owned dwelling increase until owned dwelling, right? So purchasing apartment, for example, increase and increase greatly. Also at this range, increase greatly. So positive relations, angle curve is positive, right? How about rented dwelling? Rented dwelling. Your income increase, rented dwelling decrease. Increase, decrease. Increase, decrease, decrease like this. You become richer and richer. Demand for renting apartments decrease usually, right? That is rented dwelling. How about health care? Your income increase, demand for health care increase greatly with increasing rate like this. How about demand for food? Increase, 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 and increase anyway. Clothing, increase, increase, and increase. So graphically this one is like this. What is this? What is this? This is a demand for health care. X variable is income, that is consumption of healthcare service. What happened? Income increase, demand for healthcare increase. But after this, what happened? Income increase, demand for healthcare increase greatly, isn't it? How about this? This is a demand for a rented dwelling, showing same pattern. Your income increase and increase. Demand for dwellings, owning dwellings, purchasing apartment or houses increase greatly. What is this? This is a demand for rented dwelling. This is a demand for entertainment. You become richer and richer, your consumption of entertainment and healthcare service increase greatly. This is a rented dwelling, right? Decrease, increase, decrease, and decrease, and increase. Now think about this. Here, right? Rented dwelling, income increase, decrease, increase, decrease, increase, decrease, like this. That is this one. Angle curve of annual expenditure and annual income. Income increase, demand for each service, like this. Average per household expenditures on rented dwelling, healthcare, and entertainment are plotted as functions of annual income. Healthcare and entertainment are normal good. As expenditure increase, your income increase. consumption increase with your income. Rental housing, however, is an inferior good for income above $40,000. Your income is $40,000, that is negative. Okay? So, next section is individual demand. So, as I said before, okay, so substitutes and complements of individual demand. So, what is substitutes? Two goods are substitutes if an increase in the price of one good leads to an increase in the other quantity demand for others. That is substitutes, right? Price of latte increase, then demand for latte decrease. At the same time, demand for Americano increase, right? So we said substitutes. And complements. Two goods are complements if increasing the price of one good leads to decreasing the quantity demanded of the other, right? Demand for price of latte increase, then demand for latte, consumption of latte decrease. At the same time, consumption of coffee bun decrease, right? So coffee buns and latte is a complement, isn't it? Two goods are independent if a change in the price of one good has no effect on quantity demand of the other. The fact that goods can be complements or substitutes suggests that when studying the effect of price change in one market, it may be important to look at the consequences in related market.